So, hello and welcome to a lesson about the inscribed angle theorem. And today I will show you some important definitions and words that has to do with this. It has to do with circles actually in maths. And I will prove the theorem of the inscribed angle for you. And I will show you 4 examples how you use this theorem to solve problems. Okay, so let's start. And at first we draw a circle like this. And in this circle we have a point in the middle, the central point here. And if I draw a line like this, the line goes from one part of this circle to the next one, and that line is called the chord. A chord. If I draw a line that never ends, it continues and goes like this, then that line is called a secant. Secant, like this. A secant is a line that intersects a curve in 2 points. If the line ends at this intersection, it's called a chord. It has an area inside it here, like this. This is an area, and this area is called a segment. Segments. And one thing that is important to remember in a Swedish context is that if you're at a birthday party and you're supposed to take a piece of a cake, you never cut a segment when you cut a cake. You always cut a sector. And this is a sector. So I mark it. The area inside it's called a sector. And inside this sector we have an angle here. And this angle is called the central angle. In Swedish it's medelpunktsvinkeln. These curve, part of the whole circle's curve, you see it from that point to that point, it's called the arc. In Swedish, båge. Okay, that's some important words to know. Chord, segment, secant, central angle, arc, and sector. Now, I have a question. It has to have an answer too. And the question is like this. If I draw a circle, and then I'm standing here on one point and on another point on the circumference of this circle. And I have the central point like this, and I draw a line to the center point and to the center point. Then I will have an angle. Let's call it Y. And then from this same point I draw a line to a chord actually. To one point on the circle and a line from this other point to the same point here. So I will get this angle. This is called the inscribed angle. The inscribed angle. And the question is there any relationship between y and x? And you can describe it as this. Is y a function of x? Is there any relationship between y and x? That means if I know the value on x, is it possible then to calculate the value on y? and vice versa. If you know y, can you calculate x? Well, actually you can, of course, and I will prove it for you. So, proof for this relationship. So, let's write down a circle, draw a circle like this. And I have the central point like this, and then I'm start drawing these. So, I have an angle, the central angle, let's call it y. And now from these same points I will draw to some point on the circumference of this circle, and I choose this particular point now. So when I go from this point, I go in the exact same line. So this is the chord now, and then I go from this point to this. So this is a special case of this situation. I just choose, instead of having this point, I choose the point so it's on the opposite side of the center. So I draw this line like this. So now I have x here. If I do this, it's quite easy to do the proof, but it's a special case, so it's not a perfect proof. So let's see. You see, now I have a triangle here, this small triangle, and this length is the radius of the circle, and this length is also the radius of the circle. Therefore, I have an acute triangle, and this has to be x as well, because of the acute triangle and the relationship between the angles in an acute triangle. If two sides is equal, then the angles is equal. And now you remember that we have a triangle like this, and this is an outer angle. And there is a theorem that says that the outer angle is equals to two of the angles inside the triangle when you add them. So y is equals to 2x according to the outer angle theorem. Okay, so that is the relationship. That angle is half of this angle. So I need to take this angle and double it to get y. And that's the same for this angle. I will show you that for this way of drawing the angles too. So y is equals to 2x. This is the function and the equation that describes it. Okay, let me prove it in this sort of writing it too. So we have the circle. I have the central point. I draw one angle, so I've got it like this. And then I take from the same point, so I have the same arc to a point, a random point on the circumference of the circle. So we have x and we have y, but I don't write down y and x. Instead, I take a line and I draw the line from this point through the center and on the other side. So then I have this angle. I call it y1 and this is y2. So y is equals to y1 plus y2. And they don't have to be equal to each other. If it looks like it, it's just a coincidence. I have x1 here and x2. So the angle that I want to use is x, and x is equals to x1 plus x2, like this. So let's start like this. This is a triangle, and this length is the same as this, because this is the radius in the circle, and this is also the radius in the circle. Therefore, this length is the same as this. Therefore, this angle has to be x1, the same as this. And now, according to the outer angle theorem, we know that y1 is equal to x1 plus x1, or 2x1. And we also know that in this triangle, this length is the same as this length. So y2 is equal to that angle plus that angle, and both are x2. So x2 plus x2, or 2x2, like this. Now, I want a relationship between y and x, not about y1 and y2 and x1 and x2. So y was equal to y1 plus y2. y1 plus y2. But y1 is the same as 2x1 plus y2 is the same as 2x2. So let's see what we will get. Now I can factorize this. I have 2 in 2 terms, so that is the same as 2 brackets x1 plus x2, end of brackets. x1 plus x2, that is the same as x. So y is equals to 2 times x. So, isn't it beautiful? The function is y is equals to 2x. So, this angle is double as this angle. Now, there is one last thing we have to prove, but I will let you do the proof for it. But I will show you what it is. If we have this circle, and I draw lines like this, so we have the central angle here. And then I draw from this point to this point, and from this point to this. So I will have the angle here. We have y and we have x. It's the same relationship. This is half of this angle. But can you prove it? Well, I'll let you try to prove it. You draw a line. This is you can start by yourself if you want to. But the hint is, if you take the pen and draw a line to the center and continue, so you have a chord like this, then this chord will help you. You will find good angles to use here and here. Now it's up to you to make the proof. Okay, let's continue. And I will show you 4 examples on this. They are quite tricky. Example 1. Determine x and y. So, there are many circles that we have to draw today. We have the circle here, and we have the center here, and the center angle is here. And then from this point, from the same arc, I draw this to this point and to the same point here. And from this, I also draw to a point here and a point here. And then I call this well, it's 30 degrees. Here we have an angle, and here we have an angle. This is angle y, and this is angle x. Determine x and y. If you know how to do it, you do it. And you can take a pause if you would like to think about it, and then start again. So, let me show you. This is the central angle. It is double the size of the inscribed angle, that's 30. So y is equals to 2 times 30, according to the inscribed angle theorem. That is 60 degrees. 60 degrees. In inscribed angle theorem. It's a good way to always have a reference to what you claim for your claims. Now, this angle, x is equals to 30 degrees, because this angle is the half of this angle, the half size, and that angle was 60. So therefore you can see that all angles that inscribed on the circumference of the circle has the same value. So if this is 30, this has to be 30. Okay. Example 2. Determine x and y. So here's the circle, the center point. I do like this, I do like this, this and this, and then I draw a line like this. And then this is y. I want you to tell me what it is. And this is x. But this angle is 18 degrees. Now, can you solve the problem? Then you do it. And then you can look at the answer when you turn on the video again. Okay, so let's start with x. You see this triangle? It's an acute triangle, because this is the radius of the circle and this is also the radius. Therefore, these angles are the same. So x is equals to 18 degrees. Now, acute angle is the reference to this. Or you can show it with this. Now, to find the inscribed angle here, we first need to know this central angle. Well, it's quite easy, because you know that the sum of the angles in the triangle is 180. So I write down, I give a name to this angle. I call it Z now. And I know that Z plus 18 plus 18 is equals to 180 degrees, according to the sum of the angles in the triangle. So Z has to be 180 degrees minus 2 times 18. So Z is equals to 144 degrees. Okay, I didn't ask for Z. I want you to tell me what x and y is. But maybe, or sometimes, you have to invent a new angle or so and calculate it before you can find what's been asking for. And that is y. So we know that y is half of z. And z was 144. So 144 divided with 2, that is 72 degrees, according to the inscribed angle theorem. Okay. Example 3. Determine x. Just one angle here. So I have the circle, I have the central point. And you see, I'm always start with choosing 2 points on the circumference, and I go to the center like this. But in this case, I'm starting here, and I'm starting on the right opposite side of the central here. So when I draw the line, it will look like this. You see, the chord is the same as the diameter of the circle. And then I go to somewhere on the circumference. You can choose which point you want to. It doesn't matter. And here we have x. Can you find x now? Try to. Here's how you are supposed to think. Now, where is the central angle? We need to find it. Well, this is the central angle. It is 180 degrees. You don't just see it here. So, x is the half of 180. So, if we knew it, we should have written it like this, the angle. But it doesn't matter. It could be 90 and you draw the symbol for it like this, because you don't know what it is. So, x is equals to 180 degrees divided with 2. That is 90 degrees. Like this. Okay. One last question on this. Exercise 4. Determine y. So, we have a circle like this. And then I'm standing somewhere here and somewhere here and somewhere here and here. I choose 4 points on the circumference of the circle and I draw lines between them like this. And you see it's not a perfect square or anything, it's just random points. And then I know that this angle, it's 100 degrees. And I wonder, what is this angle? This is my y. What is y? So if you want to, you take a break in the video, try to find out the answer. Here is how you're supposed to do. So let's start with finding the central point. It's somewhere here. I mark it like this. And then I draw lines to this point and to this point. And at first I wonder which is the central angle that has a relationship with this angle according to the Inscribed angle theorem. Well, it is this angle. Now it is bigger than 180 degrees. Normally it looks like this or this, but it could looks like this as well. So if this is 100 degrees, this is twice as big. It has to be 200 degrees. If you would like to, you could give it a name first. You could call it Z, and you can say that Z is equals to 2 times 100 degrees. So Z is 200 degrees according to the Inscribed angle theory. Now, if this is 200 degrees, I know I can calculate this angle. I could call it the angle A. And I know it's a full turn, so this angle plus this angle has to be 360. Now we know this angle is 200. So 200 degrees plus A is equals to 360 degrees. So A has to be 360 minus 200. That's 160 degrees. A is 160. Now, what is Y? Well, you see, Y is half of the central angle. So Y is A divided by 2, or 160 degrees divided by 2. That is 80 degrees. And if you do this many times, you will see, and you can even prove that this angle together with this angle, when you sum them, they have to be 180 degrees. The half of these angles together, it's 360, And if you divide 360 by 2, you will get 180. And these two together will always be 180. 100 plus 80 is 180. So I don't ask for it, but this angle together with this, if you add them, will together be 180. Okay, that's all for today.